So now that we learned a little bit of inductive reasoning, it's time to learn a little bit about deductive reasoning. And deductive reasoning is the process of proving a specific conclusion from one or more general statements. A conclusion that is proven to be true by the deductive reasoning is considered to be a theorem in mathematics. So, first, let's find an inductive reasoning answer to this question. Everybody pick a number. If you're watching this video, please pick a number. And I will pick the number, 3. So that's my number. And now I'll multiply the number by 6. 3 times 6 is equal to 18. That's step 1. Now I'll add 8 to the product. I'll add 8 to this, which gives me 26. I'll divide the sum by 2. That divided by 2 is equal to 13. And then I'll subtract 4. So I chose the number 3, and what I ended up with was the number 9. Subtract 4, I'll get the number 9. And so our question is, what is the rule here? So I went from 3 to 9. You should pause the video and choose your own number and see what you end up with. And without more than one example, it looks to me like the rule is just going to be multiplying by 3. So if I choose a number n, after this process, it will lead to 3n. It'll go to 3n. And I think that's, using inductive reasoning, I think that's what we're going to end up with. So how do we solve this using deductive reasoning? So using inductive reasoning, we found a rule. And then using deductive reasoning, we prove the rule. So let's go back up and use deductive reasoning to prove the rule. Well, let's select a number. Let's select any number. Let's just call it the number n. And then we're going to multiply that number by 6. So we get 6n. And then we're going to add 8 to the product. Add 8 to that. We're going to divide the sum by 2. We're going to divide this whole thing by 2. And then we're going to subtract 4 from the answer. So I want to know if this is just equal to 3n. Well, we all know at this point, because we've all taken an algebra course at some point, that to divide this piece by 2, I just divide both the pieces by 2. So 6n plus 8 over 2 is just equal to 3n plus 4. And if that's not immediately clear to you, just look at it for a second. We just divided the 6n over 2, and then the 8 divided by 2 to get our two pieces. And then we still have our minus 4. 3n plus 4 minus 4, clearly, after all these rules, we're just left with 3n, which was what we guessed using our inductive reasoning, but we proved it using our deductive reasoning. So we can use deductive reasoning to prove things, to come to complete proofs. So now let's move on to sequences. We'll do a little bit of sequences. We have a definition. An arithmetic sequence is a sequence in which each term after the first differs from the preceding term by a constant amount, by an amount that is the same each time. That amount is called the common difference. And another typo. I would imagine the arithmetic mean to be the mean when you add things, when you're adding terms. So our examples here. Our first example is write the first 6 terms of the arithmetic mean with first term 6 and common difference 4. So we start with a 6. Our first term is 6. And the common difference is 4. And we're adding each time. We have an arithmetic means add. Arithmetic mean is adding. Both start with A's. So we are adding 4 each time. So we go from 6 to 10. And then from 10 to 14, just adding 4. 14 to 18. For 6 terms, so we'll continue adding 4 to get to 22, add 4 to get to 26. That is an arithmetic sequence. So take a minute and try the next question. Write the first 6 terms of the arithmetic sequence with first term 5 and common difference -2. So in this case, we start with a 5, or we're always given our first term, and then our common difference is -2. So 5 minus 2 is 3. That minus 2 is 1. 1 minus 2, you'll remember when we jump past 0, is going to be -1. That minus 2 is negative 3. Now our values are going to be increasing with our negative sign, which means it's going to be decreasing. So we get negative 5, 3, 6, and that's our first 6 terms. So now continuing, we have a little definition here. The general term of an arithmetic sequence, or the nth term of the arithmetic sequence, with first term a1 and common difference d, if you have the first term and the common difference, you can find the nth term, you can find any term you want, with this little equation. A sub 1 plus n minus 1 times d. And we will use that formula, and I have it written on the next slide in case you didn't write it down, but you should be taking notes. We use that formula to find something like the 8th term of the arithmetic sequence, whose first term is 4 and whose common difference is negative 7. And you'll see how simple this is. You'll see what that means. So we're looking for the 8th term, or a sub 8. And we know a sub 1. We know our first term is 4. And then what happens with each step? Well, with each step, we're going to be subtracting 7. So how many 7s are we going to be subtracting by the time we get up to a sub 8? Well, a sub 1 is already 4, so we're going to be subtracting 7 negative 7s. So n minus 1, or 8 minus 1, in fact, I'll write it out, 8 minus 1 times d, which is negative 7. So a sub 8 is equal to 4 plus 7 times negative 7, or a sub 8 is equal to 4 plus negative 49, or 4 minus 49, which is equal to negative 45. And that's the 8th term in that sequence. If you were to do this the long way, you would have had to start with a 4, write the 4, then subtract 7 the first time. 4 minus 7 is negative 3, subtract 7 again, negative 10, and so on and so forth. So that's an arithmetic sequence. An arithmetic sequence is where you are adding, or you're adding a negative, which is the same as subtracting. But we all know in math we have 2 other operations, so we move on to the geometric sequence, another sequence of numbers. The geometric sequence is a sequence in which each term after the first is obtained by multiplying the preceding term by a fixed non-zero constant. The amount we multiply this time is called the common ratio. So, in these problems, we're just going to find the common ratio real quick. The easiest way to find a common ratio is just to look at the first 2 numbers, then look at the third one to make sure it agrees. So we say 1 times what equals 5? Well, it's just a 5. But then 5 times what equals 25? Also a 5. So our common ratio is just 5 in this case. Take a minute and try the rest of them. Pause the video and try the rest of them. Now for the next one, we have 4 times what equals 8? 4 times 2 equals 8. 8 times 2 equals 16. 16 times 2 equals 32, and so on. So our common ratio here is 2. Now a common ratio, just like how the common difference in the arithmetic sequence could be negative, a common ratio can be negative. So what are we multiplying negative 12 by to get to 24? Negative 12 times what equals 24? Well, we know it needs to be a negative number because a negative times a negative is a positive. We need to cancel out that negative. And then what number times 12 equals 24? Just a 2. So our common ratio here is actually going to be negative 2. And we see that continuing when we do 24 times the common ratio equals negative 48. 24 times negative 2 swaps back to negative. And now, just like how in the arithmetic sequence we were able to do subtraction by doing the opposite of the number, well, what's the opposite of a number with regards to multiplication and division? If I'm multiplying by 3, the opposite of that is dividing by 3. So in this next case, we have negative 3. How do I get from negative 3 down to negative 1/3? Well, negative 3 times what equals 1/3? Negative 3 times what equals negative 1/3? We know it's not going to be a negative number. We can cancel these out, put a plus sign. So we say 3 times what equals 1/3? In fact, it is 3 times 1/6, or we're dividing by 6. That's wrong. 3 times 1/9. 1/9. Because we end up with 3/9 equals 1/3, which is absolutely true. So you might think our answer here is 1/9. But then we're going from negative 1/3 to positive 1/9. What do we divide by in that case? What number do we have to multiply by to go from negative 1/3 times what equals positive 1/9? And this time it's going to be negative 1/3. And since our sequence is broken, since we got two different answers, a negative 1/3 here and a 1/9 here, there's actually no answer to this one. This one has no solution. This is not a geometric sequence because it breaks down, because you can't multiply by the same common ratio. You can't multiply by the same common thing here. So our next problem, let's go back to things that are geometric sequences. And we will write the first 6 terms of the geometric sequence with first term 6 and common ratio 1/3. So we start with a 6, and then we multiply it by 1/3, or we divide by 3. 6 times 1/3 is 6 divided by 3, which is 2. 2 times 1/3 is 2/3. 2/3 times 1/3, multiplying the denominators, is just going to be 2/9. And then dividing by 3 again, we're just going to get still a 2. Multiplying the bottom by 3 once more is going to give me a 27. 3, we want 6, so this is going to be 2 over 27 times 3, which is 60, 70, 81. So we just divide by 3 each time when we have a fractional common ratio. And just like before, we have a general solution. So if you're looking for the general term of a geometric sequence, or the nth term of the geometric sequence with the first term a1 and common ratio r, is going to be a sub n, the number you're looking for, is equal to a sub 1 times r to the power of n minus 1. So let's see how that works out. This slide is a little big. Find the 8th term of the geometric sequence whose first term is -4 and whose common ratio is -2. So take a minute and write down this equation, because you are going to lose it on the screen. So now our equation a sub n, or the 8th term, a sub 8, is going to be equal to a sub 1, which we're given, the first term, -4, times our common ratio, r, which is -2, to the power of n minus 1, or 8 minus 1, or 7. A sub 8 is equal to -4 times -2 to the 7th power. So let's worry about negatives first. If I have an odd power, I'm going to retain the negative sign, but I also have a negative sign down here. I'll do this in 2 different colors. This means that we're going to have a negative on the -2 to the 7th, but we also have another negative. So our a sub 8 is going to be a positive number. And now we just have to worry about multiplying 4 by 2 to the 7th. Well, 2 is easy to double a bunch of times. We start with 2 to the 1. 2 squared is 4, times 2 is 8, times 2 is 16, times 2 is 32, times 2 is 64. Times 2 is 128. That is 1, 2, 3, 4, 5, 6, 7 of them. So our a sub 8 is just going to be 4 times 128, which 4 times 125 is equal to 500 flat. So 4 times 3 is 12, so we just get 512. And that is sequences, and that is deductive reasoning.